Hello and good morning. My name is Muhammad Faiz, and today I am going to present about my project that is the fabrication of electrospun fiber using polylactic acid with different mass ratio of soot. This project is under Air Resource Lab and my supervisor is Dr. Khairul Nisa. Nowadays, pollution is a very serious problem with a lot of consequences. There are two main types of pollution. First is air pollution, which is caused by the solid and liquid particles and certain gases that are suspended in the air. The health effects include heart diseases, lung cancer, and respiratory problems. Second is water pollution that is caused by waste from household, factories, or agricultural land that is discharged into a bodies of water. This leads to the contamination of the food chain as toxin is introduced into our food. To mitigate this problem, researchers have developed a new material in the form of nanofiber. Nanofiber is a sheet of fiber joined by physical entanglement. Methods such as melt blowing, electrospinning, and centrifugal spinning is used to produce this material. It shown promising results in the filtration application. These applications are implemented in areas such as wastewater, air pollution, particulate matter, oil and water separation, and volatile organic compound. Most of the filtration material is based on carbon-based material. Carbon-based material is a top-performing material for the pollutant absorption from the air due to its advantage in high surface area, high porosity, and great surface reactivity. One of the alternative sources of this material is from candy soot. Soot is an impure carbon particle that is produced from the incomplete combustion of hydrocarbon. The tips of the flame have hydrophilic property at 86% carbon content, while the inner flame is hydrophobic at 89% of carbon content. For the problem statement, many factors involved in electrospinning. These factors include the viscosity of the solution, as it will affect the fiber formation. This study focused on the effect of PLA solution during the electrospinning process. For the gap of study, with the electrospun candy shoot, there is a lack of study for its fabrication. For the scope of the study, focusing on the electrospinning parameter, the study focused on the viscosity of the PLA soot solution. The objective include to fabricate PLA soot nanofiber via electrospinning, observe the spinability of PLA soot solution, and to study the effect of the viscosity. For the methodology, it is comprised of three steps, which is soot collection, solution preparation, and fiber fabrication. Based on the diagram on the right, flame of the candle is to be put under a ceramic crucible for 2 hours. Soot is then deposited and it is slowly scraped off. This is the overall process of the solution preparation. First, PLA is mixed with DMF, and then candle soot is then added. The solution is then shaked for 24 hours at 60 degrees Celsius, forming a black viscous solution. There are two sets of samples produced. The first is ratio set, where we maintain 38% of the solute of the solution. Second is the added set, where we maintain 38% of PLA and soot is gradually added. The solution is then electrospun at 12.8 kV with a flow rate of 0.9 ml per hour, and the distance from the tip to the collector is set at 10 cm. For the result, in the case of the ratio sample set, different mass ratio of PLA to soot is used, resulting in a decrease of the solution viscosity, and whereas sample D with the lowest viscosity value have difficulty in the electrospinning process. Based on the graph, we can clearly see the decreasing trend of the sample. This shows that the mass of PLA is an important factor in determining the solution viscosity. In terms of the electrospinning process, For sample A, a stable telecone is formed. The formation is maintained throughout the process and no spray is observed. So this is the obtained fiber which have a smooth surface, and in terms of the microscopic image, a strand of fiber is detected. For sample B, a stable telecone is formed, able to retain this formation throughout the process and no spray is observed. We obtain a smooth fiber surface and a strand of fiber is detected. For sample C, same observation can be observed. A stable telecone is formed, able to retain the formation and no spray is observed. And we obtain also a smooth fiber surface with a strand of fiber detected. For sample D, however, the telecone is not as stable as before and droplet flickering occur throughout the process. We obtain a rough fiber surface and there is no strand of fiber detected. For the added sample set, the viscosity of the solution increases as the mass of PLA remains constant for each process. In this set, only 2 samples was able to be spun. Based on the graph, we can clearly see the significant increase in terms of the viscosity of the sample. For sample E, a stable telecone is formed, able to retain the formation throughout the process, and no spray is observed. We obtain a smooth fiber surface with a strand of fiber detected. For sample F, however, telecone is not as stable as before and droplet flickering occur, same as sample D. But we obtain a smooth with a rough surface spot of fiber on the surface, and there is a strand of fiber detected in this case. For the last 3 samples, the sample form a slush rather than a solution, which is not suitable for the electrospinning process. Based on the result, we can observe that viscosity involved with the entanglement of micromolecule in the solution. So, when viscosity increases, more molecules are entangled. From this, we can observe that there is a range of suitable viscosity for the electrospinning process. At low viscosity, the solution from droplet leading to the process called electrospraying, while at high viscosity, the entanglement of polymer chain are high, thus leading to the stretching of the charged jet is difficult. So within this range, we have the optimum viscosity. So the optimum viscosity should be measured for each polymer solvent solution. So in conclusion, polymer solution with different ratio of soot are formed. An electrolytic fiber via electrospinning technique is fabricated successfully. The effect of the soot ratio has been analyzed, affecting the viscosity of the solution and its spinability via electrospinning technique. And optimum viscosity is needed for the fabrication of PLA soot fiber depending on the target fiber collected. That is all for me. Thank you.